Hello, today I'm going to talk about the design and implementation part of the project. In this case, I'm going to start with the design of the UML diagram. First of all, in this design phase, it's where we, after having and selecting our both databases, we wanted to create a working database system. And first of all, we need to create a structure on how pooled or combined database will look like to organize the data efficiently, support the queries, and then make that information consistent. So this is a big picture of our UMLS class diagram. And we could say this is a visual map of our databases components. Um, it shows the main entities we're working with and how they connect to each other, derived from the original datasets. And this diagram has different entities that will derive from the two databases. I'm going to switch tabs so we can see it closely. So these two datasets at the top, which are those datasets that we got from Google. It's a representation of both the NBA players dataset and the NBA team stats dataset. Here we are listing all the elements and or the columns that each dataset had. For example, in NBA players, we have things like the player name, team age, height, weight, etc. From NBA team stats, we have the ranking, team age, 3-point wings, etc. Based on that, we derive four core elements that we want to design as part of our database. We have our players entity, that includes details like the player ID, the name, the height, the weight of the college, and it is basically the heart of our individual player data since it contains the most important information about each player. Now, from teams, we capture the team ID and name. Uh, it's a simple entity, but it keeps the essential information regarding the teams as part of identifying information. Now we have team season stats. With team season stats, we are tracking the team's performance in a specific season, with stats like the points and rebounds tied to a composite gift of team ID and season. So we derive mostly the statistics of the game and how the teams are performing. Now we go to player seasons, and this is a junction from both the players and the teams that they played for each season, and the season it's the composite key. So we can see that is derived from teams and players. Player season derived from players and teams. Team season data is a derivation from both the original dataset and teams. Here we have our labelings of each table, of each entity, what information was extracted, where it was extracted from, and how is this information populated, and in general how the table is split, and how we want to create our database system based on that. Now, in order to understand how the database works, following the different normalization rules and to eliminate redundancy and ensure data integrity, we took some actions that will lead us to go from first normal form to third normal form in order, specifically regarding how to differentiate and extract meaningful information from teams and players and seasons. So as we saw, we have seasons data and stats data, but we want to split the player data to players and player team seasons, and this will make it second normal form. And we also want to split the team data to teams and team season stats to three normal form. Um, First of all, in first normal form, we know that this formally is already, any database is already in first normal form because every column holds a single atomic value and every row is unique. So in this case, their tables are already in first normal form. The second normal form, we have to build it out of the first normal form, and we have to ensure that non-key attributes depend fully on the entire parameter key and not just part of it. For example, as mentioned, the team season stats table depend both on the team ID and season together. In this case, there's no part dependencies sneaking in. Now, to convert it to third normal form, we need to remove any dependencies where non-key attributes might depend on other non-key attributes. For example, in the players table, everything depends directly on the player ID, not like college determining height. Uh, so for this reason, we need to split our data, and by splitting out static data, like player details into its own table, we can obtain their normal form. And once we obtain their normal form, our database will don't create any conflicts or chaos and will follow best practices in databases. For example, if a player's height will change, we update it once in the players table and not across every season they've played, and this is efficient and reliable information that can be obtained from the database. For example, in the NBA players, we have issues such as it combines the static player data with seasonal data. So in case we don't want this information to be changed all across each season, we want to each season to be independent from the player data. Since again, for example, the player may change the height, the college, etc. We don't want to repeat static attributes like the height for every season, since this will create redundancy, especially if it relates to the same player. Also, one issue we had is that the player name may not be unique, and this can be risky. It, the database can relay this information as if it was to be of the same player. Also, with the NBA team stats, we have some team names that are stored directly, but we have some inconsistencies in the different database. The same team can be sometimes referred different way. For example, LA Lakers instead of Lakers. And this way, we didn't have a clear identifier for teams beyond their name. Just wrapping up again with the steps, even though it was already touched based on. We have first normal form, which is already satisfied since each column is atomic data. For second normal form, we eliminated partial dependencies. In this case, we split all seasons row and players into players and player team seasons, and we split the stats into teams and team season stats. And for third normal form, we replace team revision with team ID, player, and team season. That way, we can identify the different teams properly. And with this, we leave the final schema of players, teams, team season stats, and player seasons. And this is a graph of the how this schema will look like. We have all seasons row and pre-game status row, and this is a big overview on how this information will look like and how it will be split.